And welcome back to our science video, the lesson number 2 in unit number 2, the electric current and cell. Of course, we speak about physics in this unit, and this lesson, of course, also will be about physics. So let's continue. This lesson speak about electric current and cell. We know from the first lesson in unit 2 that the cell here is not the human cell or animal cell or plant cell. It is a battery. It is the battery. The battery we use to operate devices in our homes, like your smartphones, your remote control. Anything is called a battery. So the electric current is generated by two methods. If you want to generate electric current in your home, so you have two methods, only two methods. Number one, changing the chemical energy into electric energy in electromechanical cell or electrochemical cell. Like the battery, they produce direct current, and we will know what is the meaning of direct current. And number two, changing the mechanical energy into electric energy by the electric generator. The generator, some houses have a generator, the hospitals have generators, so if the electric current is off, they can use the generator to generate electricity. Okay, this generator also called dynamo. Of course, you heard about it in your cars. Any car have a dynamo that generate electricity from mechanical energy of the car. The mechanical energy, by the way, is the kinetic energy or the moving energy, if you don't know this. The electric current produced is alternating current. And we will know the difference between direct current and alternating current in the next lessons, inshallah. So we have here electromechanical cell like the battery and generator like dynamo. The battery or electromechanical cell change the electricity from chemical to electric. The type of current here is direct current. And here the generator or dynamo change the energy used here is mechanical, it change it to electric. The type of current here is alternating current. Okay, so this is the figure, how to figure out the dynamo and how we can use it. We can use it in your bicycle to operate some light bulbs or something like that, or to even charge your battery. Okay, so we have types of electric current. Types of electric current, like we said, direct electric current and alternating electric current, DC and AC. You can see them in your charger, in your phone charger. The definition of each one of them. DC is a constant intensity, and alternating has a variable intensity. It's I alternate from 0 to maximum and from maximum to 0 again. The direction of DC, it flow in one direction, just one direction, while it flow in opposite directions, alternating direction. Okay. The source of DC is electromechanical cell, which is the battery of car, of anything, etc., or the sample cell or dry cell. Electric generator, of course, is the source of alternating current. Electric generator. The distance it travel. The DC travel a short distance, so you can't conduct it to a very long distance or something like that, so we use alternating current or AC to transfer over short or long distance. Okay, the uses, of course, number one is the DC. The uses of DC is to operate some electric machines such as torch or electroplating. Okay, the AC has some other uses like lighting houses, like lighting streets, operating electric appliance in houses like your refrigerator and something like that. The conversion. The AC or DC, let's start with the DC. The DC can't be converted into alternating current, while the AC can be converted into direct current. So we can say that the AC is more beneficial. We can use it in many things. Okay, connecting cells in an electric circuit. Cells are connecting in the electric circuit by two methods, series or parallel. We know some information about that from Junior 6, I think. Yeah, Junior 6. Okay, in Junior 6 we have two types of connection, series and parallel one. Okay, let's begin with the series connection. The series connection is a negative pole in the connected in the series, or the circuit is connected to the positive pole of the second cell, and so on. So if we have a cell right here and another cell right here, okay, this is positive and this is positive, this is negative and this is negative. If we want to connect it in series way, so we connect the positive one to the negative one in this, like this. Okay. Unlike the parallel, if I want to connect them parallel, so I use that like this. If I have the two batteries, yes, okay, positive and negative, and if I want to connect them, the positive one will connect it to the positive one, and negative one will be connected to the negative one, and so on. So the positive pole in the parallel, the positive pole are connected together, okay, while the negative poles are connected together. Okay, so the EMF, or electromotive force, if we want to measure the electromotive force here in the series, so just add the electromotive force of each of the electric circuit. And if I want to measure the electromotive force here, so electromotive force of one of each of the battery equal the electromotive force of the whole battery. So if you want to an example of the series, a circuit contains 4 cells connected in a series. So the EMF of the battery is equal 4 times 1.5 equal 6 volt. While the circuit contains the same 3 circuits connected parallel, the EMF is 2 volt, just one of it. Okay, let's continue. This is enrichment experiment. Okay, as we said, we can connect many lemons. The lemons here are connected parallel series, as you can see. Parallel series, of course, they are connected series. So to make the light bulb illuminate more and more. Okay. Okay, let's continue. We said that this conduction, or this is series or parallel. Of course, it is a series. Okay, we have some technological application we have here. This is called the electric transformer, and you can see the electric transformer in any device, in your charger, the charger of your phone, the charger of your laptop. Okay, any device you can see this this electric transformer. This electric transformer has a very important role in our electric devices. So we can say that is adapter. Of course, this is your charger, your adapter. This is used as a voltage converter. We know that the volt in our homes is 220 volts. Some of electric devices operates only by 111 volts, so therefore using electric supply will damage them. So this device is used to convert the 220 to 110 volt directly. Okay, types of transformers, we have main two types of transformers. The first one is called a step up, which increases the voltage, and the second one reduces the voltage. Of course, some of them we want to increase the voltage somehow. Uncut electric charger. It stores electric energy for a certain period of time. When the electricity is cut, The charger can supply appliance with electric current for a while until the current is restored. Okay, now we have finished our lesson 2 in unit 2, and I think it's easy, measy, lemon squeezy, and goodbye.